Okay, we did problem number 9 here on Friday, but I kind of botched it up there towards the end because I overthunk it. All right. Well, anyway, so here we go. So we've got, first of all, here's our info. Your info is going to be different for your problems. Now we did, what is the initial current in MA immediately after the thing is connected? Well, it's going to be, well, here's our circuit. Let's just take a look at. I've got all the information written down, and we can bounce back and forth because I've got all. And this is easy to draw. So here I'm going to put my resistor over here. Let's put the capacitor over here. I've got the voltage. All right. So immediately when I turn this thing on, here's V, here's C, here's R. Immediately when I turn this thing on, it's going to have max current and max voltage going through here because there's no charge. The charge here is equal to 0, so this charge is going to come over here and start building up. And what happens is when these protons start, actually we know it's the electrons start building up. Well, what happens? The electrons start building up, so it leaves protons on this side. So we just use the conventional current coming this way. In fact, one of your fellow students and I worked this. We actually went through how the conventional current and how the electrons move comes out to give you the same thing. So we don't have a bunch of positive charge built up here. So it's just V is equal to IR. And so it's V max, which is 6.1, in my case, it's V 6.19 divided by the resistance of 540. And they wanted it in milliamps. So when you get done, you multiply by 1,000 and you're done. Okay? All right, so that wasn't bad. And then they wanted to know, what is the RC time constant in seconds? Well, we can do that because we know that RC, here we go. And here's the equations that we're looking at. The voltage that gets stored up in here, the potential difference that gets stored up in here in the capacitor is equal to V naught. This is charging. Is equal to V naught times 1 minus e to the minus t over tau, which is our time constant. Tau is equal to r times c. Well, that's not hard. So, okay, I'm going to cut out here and stop for a second because I think I got somebody coming in.